Hi folks, this video clip is regarding the mechanism in chapter 8, cam follower, and it looks as shown here. So we have a wall, a cam, and a pin. Now I also have this ivory looking object here, which is the surface of that cam that has been extracted. This problem can be done without extracting the surface, in other words, just the cam as it stands, but since in the book I've used the surface, another point surface joint, that's how I'm going to do that. Alright, so let's move on. Let me save this thing. That's going to be file, save management, save as. On the desktop, I will create a new folder and I will call it cam follower. Dimensions are not important. I'm just showing you how the process works in these sequence of tutorials, video segments. Okay, so insert new part in there. And I'm going to call this thing the wall. So right click, properties. This is a wall and the wall. Alright. And let's do that. Double click on it. We are in part design, so on a convenient plane, on that vertical plane, I will sketch something that looks like that L cross section. Something like this. Alright, exit, add it, and I'll do mirror extent. Yeah, that looks good. Okay, so this is going to be the wall. And of course on the top I have a hole where the pin is going to go through, and on the side I have a hole where the pin is going to go through. So here is the hole for the pin. Let me see. Yep. Let me actually move it a little bit closer to the origin. Maybe even put it, really doesn't matter. Yeah, I'll put it there. Exit and make a pocket all the way through, and then we need something on the side where the cam is going to get attached to. This is the circle is for this shaft of the cam, so something like that. Exit and pocket. Alright, good. So let me change the color of this thing to something fancy, like that. Now I'm going to insert my next part, which is going to be the cam. Okay, so insert new part, call it the cam, properties, cam, and cam, and let's make on a convenient plane. On that plane I will sketch. Why don't I project that circle? There we are. Exit and then pad it. Okay, that's good. And on this face I will, this is the shaft, on this face I will draw the rest of the cam. Let me see. Okay, how about perhaps something like that? Alright, I would like to make these things tangent though. So this control that. I want to make them tangent. And this and that also tangent.
Okay. How about making this concentric with the other circle? Yeah, concentric. You're right. Concentric. What is that? Make it concentric. All right. Exit. Pad it. Okay, so that's going to be the cam. I mean, obviously, I'm going to push this thing in later on. So, all right. Now we're going to make the pin. Change the color here. Okay, let's make the pin. So insert new part and call it the pin. Properties, pin, and pin. Now when I do this thing in class, I usually don't make the tip of the pin sharp. So basically I draw a cylinder and create a point at the bottom of that circular section. However, there's something that I want to use here which may be useful for some of the students, and this is where I'm going to make the bottom of it, the bottom of the pin sharp. Okay, so on a convenient plane, say on this plane, I will sketch. Now why don't I draw an axis, because I would like to here I would like to revolve this thing, revolve the cross section of the pin around this, or shaft it around that. So there's an axis. It's a construction entity basically. So there we are. So this is going to be the pin head. This is going to be the all right. Now let me make this thing a little bit thinner, and yeah. Let me see. Yeah, that's good enough. Now, when I exit, actually, I don't think this was vertical, completely vertical. No, it is vertical. Okay, good. Somehow this looks like an angle. Anyway, when I exit that, and when I shaft it, I use a shaft, it uses that axis, automatically creates the pin for me. There we are. Now, oops, I want this thing to fit through that, so oh, I know what, my axis was not, this looks fatter at the bottom. I think my axis was not completely vertical, and also this hole is smaller than that pin. It really doesn't matter, but I want to make it look good. So double click. Yeah, my shaft is not vertical here, I'm sure. So right click, you can make it vertical. All right. And then let me see what this radius is. Let me measure this. Okay, so 0.177. Okay, that being the case, I'm going to put a dimension here between this and the axis, 0.177. So it's exactly the same size. The radius is 0.177. 0.177. Okay. All right. Okay, that's better. Exit, and there we are. Okay. Now, eventually, I'd like to put this thing in there. Let me actually go ahead and assemble it, and then we'll find out. Let me change the color of this pin to yellow. Okay, we're going to do the assembly. First, save everything. Okay, so assembly design. All right, let's anchor the wall. Anchor the wall. Right there. Okay, and then I'm going to insert this guy inside of that hole. Now keep in mind that this pin, if I just make it axis to axis, it becomes a cylindrical joint, so it's allowed free to rotate about or spin about its own axis, and that is going to give you an extra degree of freedom, unwanted degree of freedom. So what I'm going to do, I'm going to make this is prismatic as it slides up and down that hole. So the way I'm going to do that is saying that coincides the axis of the pin and the axis of the hole, and also two vertical angles, two vertical planes of the wall and the pin, the angle is maintained the same. So the constraint between a vertical plane of the wall, so for example the YZ plane of the wall and YZ plane of the pin. The angle right now is 0, so keep it at 0. That will automatically make it a prismatic joint. So let me update and move it up. Okay, good. All right, we'll come back to that later. So let's put this in that hole. So coincidence between the axis of this and the axis of the hole, and coincidence between that surface and this surface, and that's going to make it a revolute joint. All right, now, oops, I don't think this was long enough. So double click on this thing, so make it a little bit longer. So maybe 2. All right. Now, the objective, the process is going to be making this a prismatic joint later on. And this one, of course, is going to become a revolute joint. And the pin is supposed to go around that hole, around that cam. So what I use in Catia is what's called a pin or point surface joint. Now, I told you that I really don't need the surface, but I will create it. So I'm going to go to the part I'm there right now and extract these faces and join them. You can try this without actually creating the surface, and I'm pretty sure it's going to work unless it's something completely out of whack. So we're going to switch to, for example, wireframe and surface design. Where are we? That's not it. Wireframe and surface design. Right there. And I'm going to extract these side faces. Extract is right here. Look under the operations toolbar. And I think it's right there. Right there. Okay. So I'm going to double click on this. And I'm going to extract the safe faces. So here's one. Here's another one. Oh. Let me cancel this for a second. I want to show you something. I'm going to change the color of this thing to something else. So, for example, maybe orangish or red. Okay, good. Now we're going to extract. Notice that every time I select one of these faces, it turns green. That's why I changed the color. Now, if I say OK, then it's going to lose this. It's going to do the other one. So what I should do is click on that. And then select the other one. Well, I guess let me try it again. So extract. Actually, let's do it like this. We click on this bag here, and we do our selections. Another one. Click on that. Another one. Click on that. And click on this, so all the faces are selected, or you could have pre-selected all of them and one click without using that bag would have done the job. Okay, there we are. Did I do it? Let me see for a second. Yeah, right there. These surfaces are extracted. Now, the only thing is that the only thing I don't like is the fact that the color of these are supposed to be ivory. So let me hide this. There. Yeah, these colors also came out to be, generally speaking, the default color is ivory. So I will fix that in a minute. But anyway, I want to join these things. So join these surfaces. Here's the join icon. Join. These faces that I extracted, I want to join. If you don't join, the pin will only slide along one of these segments. It will not continuously go around. Okay, so you can try without joining. You'll see that when you create your point surface joint, when the point is on that surface, it's fine, but when it reaches these boundaries, it's going to stop. Join, make it one continuous surface. Let me change the color of that to the default color. I suppose, no, I guess I know what happened here. It's this, I'm going to change it back to no color. Oh, there we are. And the cam, the solid part that I created, which is hiding right now, we bring it in the front. Yeah, this one, if I wanted to, I can change it to this path, for example. I can change it to, I don't know, orange I wanted, something like that. But anyway, the reason this didn't show up is that I actually made the color way up there to red. Everything else was red. So, you know, I can hide this if you don't want it. The point that it really doesn't matter. So just keep it like this. Now, the other issue, so let's go back to assembly design and save everything. The other issue that you would like to consider is you want to bring this point and put it on that face. So obviously coincidence is the one that's supposed to work. So coincidence between, for example, this face, going to bring it down. You want to bring this pin down and that point, but it doesn't work because I cannot pick the tip, the sharp tip of this pin that I've created. This is why on class I don't do the sharp tip. I just make a cylindrical surface here, create a point there, and then bring the point and put it on that. But I want to show you something that's very useful. If you go back, if there's no point here, let me put it this way, there's no point at the tip of this pin. So if you go back to the pin, let's go back to the pin in the sketch. And let me take and hide these things because I really don't want to see those. I just want to see my my pin. Where's the rest of the pin? Oh, it's right here actually. The pin. There's the point. This is the point. See that? This sharp point. So, if you, there is a feature here which says extract output feature. Output feature. If you click on output feature and you select this point or anything in the line or any point, what it does, it creates a point for you in space. So if I exit right now, see that black dot there? There is a point in space that I have created. One thing is when you change the color of parts, some of black curves that you might have it in white, they turn into black sketches, for example. Don't let that thing bother you. So let me actually bring my hidden part in the front. It was this thing that was hidden. Alright. And remember last time I could not bring this thing down. So let's go back to assembly design and create a coincidence between that surface. I could not pick this point, but now I can because there is I've created a feature there and update. There. If I had not joined these, by the way, the point surface joint would be restricted only to that rectangular piece. But because I joined it, it will go all the way around. So first thing we're going to do, we're going to save everything. Alright, let's go to digital mockup. Get the magic wand out. Let's see what kind of joints we've got. We've got a cylindrical joint and a prismatic joint. Now, cylindrical and rigid.
You know what? I suggest that we go and create these joints manually right now. So let me delete these because I put some constraints there. I probably could have deleted them, but anyway, if there are joints that you don't like, let me delete these. Delete. Delete this. And delete that. Okay. Let's start with the revolute one down here. So we have revolute between this axis and that axis. The axis of the hole, and between the face of the cam and the face of the wall. So that's going to be revolute. Okay, let's do the prismatic one. Now with the prismatic one, we may have a bit of a problem because we need well, let's give it a try. So probably it's okay. So prismatic between the axis of this, and let me hide that, and the axis of the hole. And for planes, I can take the the YZ plane of the wall and the YZ plane of the pin. So YZ plane of the wall and YZ plane of the pin. What I tried to do was using angle constraint, but I don't know, I probably didn't think about it, or there were some extra constraints that did not allow that. So this should be a prismatic joint. Right, very good, good. So let's bring the pin in the front. I'm going to bring this joint in the front too. I don't need it, but okay, so look here. There is something called point surface joint right here. Point surface joint. So for the surface, I'll select this rectangular piece, but it's going to take the entire thing because this is all joint. Okay, and the point is that tip, that feature that I outputted, remember? And I say okay. Now, needless to say, degree of freedom is 1. And you can go and make the revolute joint angle driven. I'm not going to put any physics into this, but I'll just show you how this is going to operate. What you need to do is to specify the RPM of the revolute joint, for example. Okay, so there we are. Insert, rewind, and play this thing continuously. Good. You may want to define the speed of the crank and just go ahead and find the acceleration of the pin, etc. So let me return this thing to back where it was. By the way, it has nothing. This has nothing to do right now. I can even hide the actual cam. This is still going to work because I created the joint between the point surface joint between the point and the joint, the surface joint. Now, as I said, you may want to try this thing without actually doing the surface and see it'll work. Okay, so let's stop this.